Guys, in our last few lectures, we studied electrocyclization reactions comprehensively. In this lecture, we'll see second type of pericyclic reactions, that is sigmatropic reactions. We'll define these first, and then uh, we'll take an example. The definition is sigmatropic reactions are intramolecular reactions in which 5 electrons gets rearranged. First thing is these are intramolecular reactions, and the second thing is in this reaction 5 electrons gets rearranged. You will understand more when we see this example. This pi bond will be shifted here, this sigma bond will be broken, and it will help to form the new pi bond. This pi bond will be utilized for the formation of new sigma bond. So we'll get this product will get here. This sigma bond is broken here. New sigma bond formed here. We'll observe the properties here. First thing, it is intramolecular reaction. You know that it is a intramolecular reaction. Second thing, 5 electrons got rearranged here. Look at here. Earlier, 5 bonds were here, and they rearranged to come here. Third thing is number of 5 bonds remains same here. Number of 5 bonds remains here. 2 in the reactant, 2 in the product. Number of 5 bonds remains same. Fourth thing is sigma bond broken in the reactant and new sigma bond formed in the product. So one sigma bond will be broken and one sigma bond is formed in the product. Fourth one. And the fifth thing is naming sigmatropic reaction. How to name these things? We should start numbering from the bond where it is broken. So 1 1, and we should continue till the place where new bond formed. So here between this new bond formed here. So the name of this reaction is 3,3 sigmatropic reaction. We studied properties of sigmatropic reaction informally. We'll see these one more time. First properties, these are intramolecular reaction. Second thing, in this reaction 5 electrons gets rearranged. Third thing is one sigma bond broken in the reactant and one new sigma bond formed in the product. Fourth property is number of pi bonds remain same in the reactant as well as product. In electrocyclic reaction, the number of pi bond will be less in one pi bond will be less in the product when compared with the reactant. Whereas in sigmatropic reaction, number of pi bond will be remain same both in a product as well as reactant. Naming of sigmatropic reaction. You should start numbering from a bond which it is broken, continue up to where a new sigma bond is formed. So this we understood by taking an example. Next we'll see some examples of sigmatropic reaction. This is the first example. This bond will be broken and here it will shifted to form a new pi bond. This pi bond will be shifted here to form a new sigma bond. This pi bond will be shifted here. So we'll get this product will get here. How to name this? I already told you. Start numbering from the bond where it is broken. 1 1 and continue up to the place where new sigma bond is formed. Between these, new sigma bond is formed. So it is 3 3 sigmatropic reaction. 3 3 sigmatropic reaction. Next we'll see is second example. Here this bond will be broken, this will be shifted here, and this pi bond will be shifted here. The product for this one is we'll name it by numbering here. You know that the bond which is broken, there we have to number second here, third here. So the new bond is formed between 1 and 3. So the name of this reaction is 1 3 sigmatropic reaction. Third example. Here this bond will be broken, this will be shifted here, and this will be shifted here. Count the number of carbon atoms here. This one is first, second, third, fourth, fifth, and sixth. So the product will be 6-membered ring, and there will be a one double bond. We have to name this. You know that the naming where the bond is broken will number there 1 1 2 3. So the new bond is formed between 1 and 3. So it is 1 3 sigmatropic reaction. 1 3 sigmatropic reaction. We'll see the fourth example here. Here the change is they have given the reactant as well as product. We have to find what type of sigmatropic shift here. Identify the sigmatropic shift here. So look at here. Deuterium they have given, and there is nothing, means one more hydrogen is here. The position of deuterium is shifted here. See, from this to it came here. So we'll shift this here, and this will be shifted over here. And what will happen here means this will be there, this hydrogen will be remain same, and when it is broken this forms a D plus here. So this negative charge attacks the positive charge, and there will be a formation of what, this new sigma bond. We should name it from the where the bond is broken. Here we have to name 1 1, this is 2, and this is 3. So this is 1, this is 2, 3, this is 1. So the bond is formed between what, 1 and 3. The name of the reaction is 1 3 sigmatropic reaction. We'll see a fifth example. We'll see. Observe the reactant. D is here, and in the product also D is remain here only. This time hydrogen got shifted here. So we'll shift the hydrogen here. This pi bond, it will be presented as a negative charge, and this negative charge react with the H plus, and there is a formation of new bond here. So we'll name from where the bond is broken 1 1. Sorry, here we have to name 1 1. This is 2, and this is 3. So here also the name is what, 1 3 sigmatropic reaction. This H will go here, and H plus will become, and negative charge will be there here, and this will attack. We numbered this as a 1, here it is 3. So between 1 and 3 the new bond is forming. Because of that this is 1 3 sigmatropic reaction. Look at here, sixth example. Here CH3 is there, it became CH2. Here CD2 is there, it becomes CH2. So one of the hydrogen is shifted to this place. What we'll do, we'll make it CH2, and we'll write H like this. will shift this here. This will be shifted here, and a negative charge will be created over here. So we'll write the intermediate here. This will be a CH2. This CD2, negative charge will be there, and H plus will be there. This negative charge will attack H plus. We have to number here to name this one. Here it is 1 1, 2, 3, 4, 5 will be there, and this H plus will come here. So this is the number 1. Negative charge attacks positive charge, and there is a formation of new sigma bond will be there. So it is the new bond is formed between 1 pi. So it is new 1 pi sigma tropic reaction. Seventh example we'll see here. Look at here. Deuterium is here. Its product, it got shifted here. So what is happening here means this will be shifted to this place. The negative charge will be created over here, and this negative charge will react with the what, D plus, and the new sigma bond will be here. We'll name this one. Here we'll write 1 1. This is second, and this is third. And the new bond is forming between 3 and 1. So it is 1 3 sigma tropic reaction. Observe this example here. D is remains in its position only. What is happening here is the hydrogen got shifted. This hydrogen will be shifted here. This will be represented as negative charge, and this negative charge reacts with the H plus. We'll name here 1 1. This is second, this is third, and this is 1. So this reacts with this one. So it is 1 3 sigma tropic. You can mention this as a hydrogen shift. This is 1 3 sigma tropic deuterium shift. In this case, it is also 1 pi sigma tropic hydrogen shift. Here it is 1 3 sigma tropic hydrogen shift. And not out here, it is deuterium shift. This is it. In my next class, we'll see some important name reaction which comes under sigma tropic reaction. There are 5 important name reaction. First one is Claisen rearrangement. Second one is Somerlet-Hausser rearrangement. Third one is Cope rearrangement. Fourth one is Fischer-Indole synthesis. Fifth one is benzene-benzidine arrangement. These are very, very important name reaction which are appeared in competitive exams like CSR NET, KSET and GATE many times. So we'll focus these things in my next video. Thank you for watching.